Right. Hello, class. This is Nicholas Szostek.
I'm Michael Paiva.
This is our week 3 PowerPoint and progress report. All right. So this is our concept fan for our ammeter. We have the current sensor, which could either be a Hall effect sensor or a shunt resistor. We have the data storage and connectivity, which we could use a USB, a micro SD, and or a Bluetooth. Then we also have our display, which we could use the touchscreen, a 7-segment LED, LED pixel, and LCD that we've been bouncing around ideas for our concept fan.
This is our concept table. It goes over pretty much what we had in the concept fan. It's the same thing that Nick just said, our possibilities.
And then here's our strength and weakness table. So as you can see, for the strengths for the Hall effect sensor, it is non-invasive. It has electrical isolation throughout the whole system. It has a wide range of current capability, which is very effective when you could use this application. Its weaknesses is that it's a little more expensive than what we would like. The measurements aren't very accurate compared to a shunt resistor, and it's very poor when it's linear. For the shunt resistor, the strengths are it's very simple to use, it's not very expensive, and it is extremely accurate compared to a Hall effect sensor. The weaknesses are that it has a high power dissipation, so temperature may cause non-linearity, and it requires high impedance buffers.
So this is our concept selection matrix. We decided to go with the shunt resistor. The biggest benefit of the shunt resistor is its accuracy.
Yeah.
I mean, that's the main goal of our project, is to be accurate. So that's a big one. And then the ease of maintenance is great on that one as well.
All right, simple and inexpensive, all that good stuff. All right. So here's our level 0 functional design. We would have the ammeter right there, and going into it would be the current flow, the brightness controller, and the power from the 12 through 15 volt DC, and it will be displayed on the LED pixel display. And as I just said before, the modules, the ammeter, the inputs are the current flow, the power supply, and the output is the LED pixel display. And it will be, it will show the current drawn at 0.01 amps. And
so this is our level 2 functional design. You can see we put in the shunt resistor. We need an ADC, which has to be pretty high accuracy for to read such a small value. We're feeding that all into a microcontroller, which will then output to, we're going to use 7-segment LED drivers to drive the LED pixel displays. It just makes it much easier to control those displays, and doesn't take up a lot of pins from the microcontroller. Also from the microcontroller, we have the non-volatile memory, which will store all the data, and then the power supply that will take the 12 to 15 volts and output steady 5 volts DC. This is just the description of all those things. Like I said, the ADC has to be very high accuracy. The microcontroller has to have enough processing power to simultaneously drive the displays and read the data from the ADCs, or the ADC.
this is the level 2 functional design. So we have the power of from the 12 through 15 volt DC going into the smoothing filter. And then from there, it will go into the step down converter and convert down to 5 volts DC. And this shows that the module smoothing filter takes the noisy vehicle power and removes the noise, and it steps it down to 5 volts.
These are the alternative designs that we considered. I mean, the only other possibility would be the Hall effect sensor, but it is generally more sensitive to ambient noise, which there's a lot of noise inside of an engine compartment. And then it's not as accurate at low currents, which when you have nothing on, when the engine is just running, it's very low current coming from the alternator. And the other thing is it can be difficult to secure those because it does have to wrap around a cable, and there's not a lot of mounting options for that.
Yeah.
So it could wear the cable out.
All right. And that is our week 3 progress report.